All right, we're going to go ahead and wire up a series circuit here, just a basic LED and resistor. All right, so down here I've got my power in, so I'm going to put black into this blue strip. Remember on the breadboard, this entire column right here that I'm going down, the blue line, that's all connected in one spot underneath. Okay, so anywhere I plug in here, I can plug in here, I can plug in here, I can plug in here. Okay, any one of those places, it's all the same connection. Same with the red. Anything that's going in this direction here that's parallel to this red line, anything in there would be red, 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 and so on and so forth. All right, so just to review also on the breadboard across, so this is pin 40 right here. These are all the same. So any spot in this hole across here is the same thing. It is not the same as these, okay? These will be separate than these, but everything in this entire row is the same. Everything in this entire row is the same. What happens here and here is two completely different attachments. So if I put the pin in here, okay, I can put a pin in here and I don't get anything that's the same signal. So you can see the different numbers on here. But so know that everything that goes across in rows, that's where the connections are made. So we got to make sure that we understand how we're going to wire this in series. Remember, series, we have one complete path. So I'm going to take a jumper wire here from my red. All right, I can put it anywhere I want over here in the red column. So I'm going to put it right there. It's going to go in red, and let's plug in somewhere up here. I'll plug in 35 just so we have a reference number that we can look at when we're doing this. Okay. So, one other thing that I want to show you on here is the LEDs, okay? See how there's a long leg and a short leg? The short leg is the negative, okay, or the cathode end, and the long leg is the positive or the anode end. And it's important that we put the polarity correctly or the LED will not flow. So for us, I'm just going to say red to black, make sure it goes in this way. But before we do that, we don't want to blow up the LED, so we need to make sure that we have a drop resistor in place. So we covered resistors in class. All right, so we should know, I think I'm using a 180 ohm resistor here. So as long as I put the resistor anywhere in this row, I will get the connection from the red. So the red's going to come through here, okay, through my jumper wire to this pin, and I'm going to put my resistor in the same exact row. And then I can drop my resistor down here into any other row across the jumper. These jumpers are here, okay, these divots in the breadboard so that you can do an integrated circuit and breadboard to each side and it doesn't short the circuit. All right, so now I'm going to take my LED. There's also a flat side on the LED too. It's tough to tell when you hold it up close. You'll see in class the flat side is also the negative side too, goes with the short leg. So I'm coming from red, let's call that positive, okay, because I've put red in over here from my power supply. Going in red, 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 we'll call red positive. So positive, so we have to go positive first here. Anywhere next to that resistor that's in the same row, I have to put the long leg in. Okay, and then I can end it over here anywhere I want. All right, it's ending over here in a different row. So as long as I put the long leg in, everything's good. All right, and then we have to complete the path. Remember, it's a series circuit, so I need to complete the path. So I'm going to plug in anywhere over here that's in this out leg of the resistor. If you can kind of see down, see the legs on the resistor down in here. All right, you can kind of see probably in that view how where the resistor is. All right. So the leg for the resistor is going to go right into here, and then I'm going to complete this path over here to, let's call it the negative side. All right, so in this series resistance, the power is going to go through here, the electrons, through the resistor, okay, through the LED, out of the LED, through the return wire to the path to the power supply. So when I turn it on, right, my LED lights up. So that's a series circuit, just a basic series circuit. What happens if I disconnect the leg of the resistor? The series circuit goes out. So it's just like this is creating an open. So I've disconnected this. So this is like when your Christmas lights go out. All right, you've shut down the path for current to flow. So there is some slow dissipation here, so I'm going to turn off the power supply in a second, and you can watch the electron flow dissipate out through here. So I'm going to go ahead and hit the power supply off now. And then it's slowly going to fade out, and you're going to lose the electron flow. So you can see as the current dissipates through there. All right, so this is a basic series circuit. Okay, so now we're going to take the basic series circuit we did. I'll turn it on so you know that it's in series. Okay, I'm going to wire this while it's live so you can kind of see what happens, all right? I'm going to create an open, no electron flow, and I'm just going to put this guy over here. This is safe to touch right now, nothing. I'm going to add another LED in series, and once again, I have to go positive to negative. Let's deem it that, all right? So we're coming in positive over here, positive here. This is the positive leg of this resistor, and this is the negative leg of that resistor. So what I have to do is I'm going to bend the resistor down so that you can see, or not resistor, this is an LED, I misspoke. All right, there's the negative leg of the LED. I've got to take the positive end of this LED and put it in the same row as the negative end of the existing green LED. Okay, so this is the long end of the yellow LED over here. All right, and it's in the same row as the short end of the green LED. And I still have the power flowing right now. So what you can see is when I complete the circuit, I've got to take the path and put it on the negative end or the short end of this LED, the amber LED, to complete the path. All right, so now I have two lights in series with one another. The resistor is there for protecting it. All right, so they may not be as bright this time around. Okay, so let's add another one and let's see what happens here. All right, so let's hold this off. Taking a red one. All right, let's put it in. Remember, keeping track of the long leg going to the short side of the amber LED. All right, and then I'm going to complete the path. And now I've got 3 LEDs in series. All right, doesn't matter where I put them and connect them. It matters, it doesn't matter where I put them on the board, but the connections do matter. All right, and so what happens is if one of your LED blows on your Christmas lights, all right, they're in series. These two might not be bad, but there's an open now, and the path can't be completed. So that's what series is, and that's why it's one path for current to travel through. Since there's only one path for current to travel through, when I remove any one of these LEDs from the circuit, the others will go out. This is one series path. So we're going to be doing a lab where you guys actually breadboard a series circuit. And we need to be able to understand, okay, what's going on here in the series circuit and how there's one path for current, but there's a different voltage drop. How do we know that? Look at the different voltage drop. I don't know if you can see it in the picture very well, but notice, all right, this guy's starting to get dim, okay? There will be a different voltage drop across each one of these LEDs, okay, and this resistor. So let's show how another resistor in series will impact the lights. All right, so I'm going to add another resistor that's the same size. All right, and we're going to add it so that it is in series. So I'm going to connect up here. All right, notice I make the break there so nothing's working. Put these in. Notice that they're noticeably different. I don't know if you can tell, but they are noticeably different because I am limiting how much current can go through to these resistors or through these LEDs now. So there's more of a voltage drop. I'm starting to lower the amount of current that can go through these. All right, so let's add one more resistor in series here. So I'm going to put one more resistor in, and we'll kind of see what happens there. When we do this, hopefully I set this up so we can reach them. I'm going to drop this one down here a little bit so I can reach it. All right, and notice now they're even more dim. Okay, so you can kind of see the difference, right? We're limiting the current here because now I think this is 180 plus 180 plus 180. So these are this one's getting very dim, all right? So if I take these out, Notice how much more bright this one becomes. Okay, I'm impacting the amount of current that can flow through the resistors through the LED, affecting the light. So you guys are going to do a lab where we successfully wire up in series. Alright, so we're going to go ahead and take a look here and see if we can read some voltage drops using our meter here. Alright, we're over here on DC voltage. Okay, so we should be able to read the volts. Right now on the power supply I have it set to about 6 volts. So I should be able to read across this resistor here, and I'm getting about 0.45 volts. Okay, then I can read across each one of these LEDs. This is negative 1.9. Why is it negative 1.9? Polarity. Alright, so if I switch the red and the black terminal pieces here, alright, notice now it's positive if you can see what we're reading there. Now it's 1.9 positive DC, and then I can read the same across this LED. I should get 1.9 and I should get 1.9, but this one's going to be off just a little bit because we can tell there's going to be a loss, but the sum of these should all add up to 180, and most likely, assuming these have the same internal resistance, obviously this one has a little bit more, we should have the same voltage drop across each one of the LEDs, and then we have the voltage drop here across the resistor. Let me change the polarity so you can see that piece. Okay, and we saw that that was and stuff on this little program and to video this. All right, so 0.45 roughly. Now if I measure from here, all right, to here, so I'm going to measure across the entire series circuit here. If I can get my hands to hold steady on here for you, all right, we should get the entire voltage drop of the load, and it's saying open load. Why is it doing that? Well, I have 6 volts that I'm applying. My meter's only going up to 2 right now. It can't read it. So I have to turn the meter here up to 20. So I can read up to 20 volts now. So now I should get a reading when I put the probes across. And now look, I'm getting, okay, so that's why it's off just a little bit. That power supply is putting out a little bit more than 6 volts. So if I sit here and take a reading now, that's the entire voltage drop across this circuit from one end to the other. So the voltage drop through the resistor and the 3 LEDs is 6.12. So if I add these up, all right, I got 0.45 there, and then we come over here, and this one was like 1.9 roughly, right? 1.9 plus 1.9, and this guy was a little bit less, right? 1.8. If I can hold steady on here and get a good reading for you, 1.84. So if we add up those individual voltage drops, that's the total source voltage drop, which I have it turned to 6, but we can see that this supply is obviously outputting just a little bit more than 6 volts when we take that reading. We're reading out 6.12. So there's how we use a multimeter, okay, to read a voltage drop across the component, all right, in our series circuit here. Okay, now we're going to learn how to take a current reading with the same circuit that we've been working with. Okay, so we have 3 LEDs here that are in series with a resistor. And last time we read how to take a voltage drop across it. So now with to read the current, all right, I have to put the meter in series with the circuit. So what I've done, all right, is we brought a wire out of the breadboard here where the resistor is going into, and also a wire that connects to the LED right down in here. Same pinhole row for that. And we go, you know, in through here, out into the meter, and then through the meter and back out. So you can kind of see where the connections kind of go and how it's going to roll through the meter when we do this. So nothing's on. I have the meter off in the off position right now, and I do also have the meter sitting ready to go. The power supply is on, so the second I turn the meter on and go to the right current, all right, we're going to be able to pick something up. All right, so right now, see how the meter's on. Lights are flashing a little bit. We got some issues with inside the meter. We're not really making Christmas lights here, but what's going on the meter, all right, is we can see the current that's going through the circuit. So notice nothing happened until we turned the meter on, because the meter completes the path. So the meter has to be in series, right? Watch, if I turn the meter off, okay, we're creating an open and the circuit's not going to work. But I turn the meter on, all right, and I turn it to the correct thing. We're reading up to 200 milliamps here. If I go down to microamps, all right, we're not going to get a good reading. Okay, so if you're going to get something like that, you got to be in the realm of what you're reading. So right here, it's more current than that. So we need to read up to 200 milliamps right now, DC amps. So you can see I have the meter set over here, 200 milliamps, for us to be able to see and learn how to take a reading using a multimeter. So the multimeter has to be in series with the circuit in order to read the current. So that'll always be a test question. All right, the next reading we're going to take is being able to read resistance across a resistor, okay? So I've got my resistor, and remember, to read resistance we have to remove the component. I had an extra one of the same resistors that were in the circuit that we just watched, and it's sitting right here. I've got it clipped to the meter, a couple alligator clips into the meter. Now, I'm going to do something here on purpose so that you understand when you're going to mess something up in your reading. All right, I have to put the probes in a specific position to read current down here. So there's two different probes. One has a different fuse for higher rated current. So we just read current, so I have it sitting here. But the problem is when I sit here and turn this, and I come over here, and I start trying to read resistance, this is in the wrong location. So that's why we're getting that noise, really irritating buzzing noise. So what you need to do to fix that, okay, if we're having issues, it's because we don't have the probes in the right location. This is only to read microamps and milliamps. This is to read amps up to 20 amps. Over here is where we read voltage and continuity, and we can check diodes and all sorts of things here. So I'm going to switch this over to here, all right? And now when I move it over here, there's no warning sound. Okay, so that's a good thing. So now I'm going to read over here at roughly, sorry, we're blocking the light here, 197 ohms, okay? So when we kind of see through here, all right, so you can see that we're reading the 197.9 ohms. I've got the resistor removed, all right, from the circuit and sitting right here. I've got it across, and you can also read the color code on this, but it's a lot harder to see when you read the color code, right, versus being able to take your reading. So it's 197.9. So for us, that's a 200 ohm resistor. Remember, resistors have, this guy has a gold band. You can't really see it right here on the edge because I can't get a good focus off the camera, but it's the gold band, so it's plus or minus 5%. So that means 5% of 200, right, is 10 ohms. So it can go up 10 either way when it does this. So it can go all the way down to 190, or it can go all the way up to 10. But so that's why we're at 198. We consider this a 200 ohm resistor, all right, even though it's accurately only doing it 198. So that can change our current just a little bit, but for the most part, based on the carbon properties, that's what the tolerance does. So there's how we actually take a reading on a resistor or a component, right, to see its total resistance. It's been removed from the circuit. So just to recap, when we read voltage across the resistor while the circuit was connected. To read current, we had to break the circuit, attach the ammeter or the multimeter in series with the circuit to read the current, and then in order to read resistance, I had to remove the resistor from the circuit and take the reading in ohms here. And it'll change, you know, as you go up, the tolerance is a little bit different. So this tells us it's 198. This will read up to 2,000 ohms here. This reads up to 200. All right, so we're right kind of at that threshold here, reading about 200. And it can vary a little bit as I move the wire around and things like that. If I move it up to the 2 kilo ohm portion on the meter, okay, what am I reading now? I'm reading 0.19. Means the same thing. Remember, it's in kilo ohms, so I got to move the decimal place 1, 2, 3 places to the right. All right, is it going to be as accurate? No, it's going to tell us that it's reading at about 190 ohms. Okay, so for accuracy, be more in the realm of what you want to read. This is the most accurate reading of this resistor right here, but I can read it, you know, in up to 20 kiloohms or, you know, 200 kiloohms. It looks like it's 0.1. All right, so make sure when we're using the meter that we are in the correct, you know, spot for where the resistance should be. All right, so that's another way to troubleshoot this. If you put this on and you're getting these kind of readings and you're like, oh, I'm not getting resistance, the resistors, but it doesn't mean it's bad. All right, check all the different realms on the meter here. So notice as you toggle down, the resistance is changing. So it's not necessarily the resistor's bad. It could be the setting, you know, of the resistance that you have on the meter as well. So there's wrapping up series circuits for you.